New washing machines are basically garbage now, and the industry spent 30 years making sure you would never find out why. The average washer today lasts half as long as the one your parents owned. The price tag is the same. The machine inside is not. You are paying full price for something built with an expiration date already stamped on it. Washing machines from the 1950s and 60s lasted 30 to 50 years. Some are still completing cycles today. Your grandparents bought one machine, maybe two in their entire adult lives. The parts were metal. The design was simple. When something broke, a repair tech came out, swapped the part, charged you less than the cost of a dinner, and left. The machine kept running. Today, the average washing machine lasts 10 years. That is the number researchers arrived at after tracking hundreds of thousands of units across real households. 20% of machines do not survive 5 years. Not budget machines bought on clearance. Standard. Household washers sold at full retail price at every major appliance store in the country. The lifespan shrank by 2/3 in under 50 years. No recall was issued. No regulation addressed it. The machines just quietly got worse, and an entire industry built a business model around the replacement cycle that followed. A machine that lasts 30 years is a customer who never comes back. A machine that lasts 10 is a customer who comes back 3 times in the same window. That is not an observation. That is a business strategy. Here is how they executed it. The first move was the drum. In an older washing machine, the bearings that support the spinning drum were separate, replaceable components. When they wore out, a technician pulled them, installed new ones, charged you around $50 in parts, and the machine ran for another decade. That repair existed in appliance manuals going back 70 years. It was routine. Starting in the late 1990s, manufacturers began sealing the bearings directly into the outer drum housing. The bearing and the drum became one single fused unit. When the bearing fails, and bearings always eventually fail, they are wear components by definition. You cannot replace the bearing alone. You replace the entire drum assembly. That repair costs between $400 and $900 on a machine that costs $600 to buy. Most households look at that number and buy a new machine instead. That is not a side effect of the design change. That is the point of it. The second move was quieter. The outer tub, the part that actually holds the water, the part you have never seen and were never meant to see, used to be made of stainless steel or porcelain-coated metal. Manufacturers replaced it with plastic, lighter, cheaper to produce, and it cracks. Not in year 1, not in year 2. It cracks around year 6 or 7, right when the machine is just old enough that spending $300 on a repair feels unreasonable. The crack appears, water leaks, and the machine that costs $600 is suddenly a problem nobody warned you about. The plastic tub did not end up in the machine by accident. The third move is the one that locked the whole system in place. Electronics. A washing machine used to have a timer dial, a water level switch, a motor, and a pump. Every component was mechanical. Every component was fixable with basic tools. Replacement parts cost under $30 and stayed available at hardware stores for decades. Modern machines run everything through a central control board. Water temperature, cycle timing, spin speed, drain activation, all of it managed by one circuit board sitting inside a humid laundry environment. When it fails, the board alone costs $200 to $500 to replace, before labor, before diagnostic fees. Moisture corrodes the connections over time. Power surges destroy it in a single event. Manufacturing defects surface around years 3 to 5. The board was not built to last. It was built to a cost target, but the electronics move had a second layer built into it. Parts availability. Manufacturers stop producing replacement components for a given model within 3 to 5 years of that model launching. The machine is still well within what should be its useful life. The repair is straightforward. The part simply does not exist anymore. The manufacturer already moved to the next model. The internal architecture changed, and your specific board is no longer in production. You find this out when the technician calls to say nothing can be sourced. The co-founder of iFixit, the largest repair community in the world, said it directly. The goal is to make the cost of repair comparable to the cost of replacement. Remove that argument and the customer stops calling the repair shop. They call the store instead. Sealed drums, plastic tubs, control boards with disappearing parts. These are not three separate oversights across three separate decades. This is one strategy, executed quietly across an entire industry. Now here is where it gets harder to dismiss as coincidence. In 2006, Whirlpool acquired Maytag. That acquisition matters more than most people realize. Maytag had spent decades building machines that outlasted everything around them. The Maytag repairman sitting alone with nothing to fix was not a creative exaggeration. Repair technicians who worked through the 1980s and 1990s will tell you the same thing without being asked. Maytag machines from that era still show up in shops today because they are still running, and owners want to keep them going. The machines built under Whirlpool ownership do not carry that reputation. The name stayed on the door. The engineering standards did not follow it through. That acquisition was not an isolated event. It was part of a pattern that reshaped the entire appliance industry across 2 decades. Brand after brand was absorbed, consolidated, or gutted by private equity looking for margin. Plastic replaced metal. Sealed assemblies replaced serviceable components. Cost targets replaced durability targets. Every brand that got absorbed eventually started building machines the same way. The brands still exist. The commitments those brands were built on mostly do not. And every major manufacturer ended up in the same place, building machines the same way with the same lifespan, pushing customers toward the same replacement cycle. That kind of alignment across an entire industry does not happen by coincidence. Here is what the cascade looks like inside your machine once the design has already been compromised. The drain pump usually goes first. It is a small motor that pushes water out of the drum after each cycle. Over time, lint, coins, and small debris get pulled into the pump and jam the impeller. The motor works harder to compensate, overheats, and eventually burns out. You notice it when water sits in the drum after a full cycle, or when you hear a loud hum but nothing drains. Catching it early costs $60 to $80. Ignoring it puts stress on every connected component and opens the door to failures that cost 10 times that. The control board follows. It sits in a humid environment, cycling through temperature changes thousands of times. Moisture corrodes the connections slowly. One power surge from a summer storm can fry the circuitry in a single event. When the board goes, the repair quote comes back at $200 to $500 before labor. Research tracking real repair outcomes found that electronics had the lowest repair rates of any component in washing machines. The reason is not that the repair is complicated. It is that most people see the number and scrap the machine instead. Then the bearings. Once a sealed drum bearing fails, the repair quote exceeds what most households are willing to spend on a machine they already distrust. So they replace it. The machine goes to the curb. A new one comes from the store. The cycle repeats. Each of these failures is individually manageable if caught early. The industry profits because most people never catch any of them early. There is no dashboard warning light. There is no notification. There is just a machine that works one day and does not work the next. Now here's the part most people skip entirely when they are standing in the appliance aisle deciding which machine to buy. The warranty. A 1-year warranty means the manufacturer expects the machine to survive 12 months without a major failure. That is not confidence in the product. That is a legal baseline. Most things survive their first year. The failures that cost real money, bearings, control boards, cracked tubs, emerge between years 3 and 7, well after the warranty has expired and well after parts availability has started shrinking. Research surveying over 1,000 appliance owners found that consumers are willing to pay more than 30% above retail for products backed by a longer guarantee. Manufacturers know this. They have the same data. They still ship machines with 1-year warranties. That gap between what consumers want and what manufacturers offer is not an oversight. It is a position. The warranty document, not the marketing page, not the spec sheet, tells you what the manufacturer actually believes about the machine they just sold you. Most buyers never read it before purchase. They read it later, usually while on hold with a customer service line 3 years in asking why a repair is not covered. The two questions that cut through everything else are simple. Can the bearings be replaced independently, or are they sealed into the drum? And what does the full warranty actually cover, for how long, and on which specific components? Those two answers tell you more about the machine than the finish options, the cycle settings, or the number on the price tag. Speed Queen builds residential machines on the same platform as their commercial laundromat equipment, tested to over 10,000 cycles before leaving the factory. 7-year full warranty, stainless steel tub. Replaceable bearings, starts around $1,000. Miele tests every machine to 10,000 hours in the factory, the equivalent of 20 years of normal home use. Parts are guaranteed available for 15 years after any model launches. They cost between $1,600 and $2,500. People who buy them keep them for decades, $1,200 once, or $600 3 times across the same lifespan. The spend is identical. 1 machine works, 3 do not. The industry is counting on you to keep doing the math wrong.